So when I came across Lucy's TED Talk, I just knew I had to try to get her to come on to GeoHug to have a chat with us. So I'm thrilled that she said yes. She's an inspiring woman. She's passionate about making the industry a more diverse place to work. And she's a strong advocate for the standardization of sustainable and responsible practices in mining. So I can't wait to hear from her today about mining and the energy transition. So it's going to be a great session. Use the chat. You'll be able to jump off mute at the end of the presentation, and I hope you all enjoy it. So thank you so much, Lucy. I'm so happy that you're here.
Brilliant. Well, thanks for having me. And I'm not entirely sure how to follow that start now. Yeah, it's just turned 7 AM here in the UK. I'm talking to you from Cornwall, right in the southwest of England. And I was talking to Jessica just beforehand. I've also got a new baby daughter, so might not be at my sharpest today, but I'm really looking forward to talking to you about my thoughts on mining, the energy transition, and looking at the work that we're doing down here in Cornwall actually as an example of potentially, you know, how the industry can move to becoming more responsible, because there's so many opportunities out there, and there's absolutely no way that this energy transition can happen without the mining industry, but we need to do it as responsibly as possible. Right, with no further ado, I'll jump in and start talking, but yeah, please, if you've got any questions or thoughts or anything that you want to share as well, it would be great to have a chat about that afterwards. So, right, off we go. So my name's Lucy. I'm based down in Cornwall, which is the southwesterly most part of the UK, and I'm a geologist by training. I did my master's at the Campbell School of Mines, which is the UK's pretty much only mining school now. There's the Royal School of Mines up at Imperial College in London who might dispute that, but it really is the kind of only vocational college now, I'd say, within the whole of the UK. And mining really isn't something that we've done here for metals anyway for the past few decades. You know, we've still got a fairly active quarrying industry, but when I started off my geology undergraduate degree, if somebody had said to me then, oh, you know, in 5 years' time you'll be working in the mining industry, I wouldn't have believed it, because we don't have that industry here, and we have no visibility of it in daily life either, really. That phrase that if something hasn't been grown, then it's been mined. And, you know, everything we use in our daily lives has been extracted from the ground in some way or another, pretty much. That kind of connection really doesn't seem to exist that much over here. You know, we do a lot of schools outreach, and we go in and we say, oh, you know, we talk about mining, and get questions from the kids like, do we do mining anymore? Like, why do we need it? And people genuinely don't even think about it in their daily lives. I remember I went to Australia actually a couple of years ago for New Year, pre-pandemic world, and it was great. You know, went to Sydney and saw the fireworks on a boat for New Year's Eve, and it was amazing. But what's really surprised me, same with my friends, is that mining companies would actually advertise on TV in the breaks, and that appreciation, that link between raw materials, where they come from, and the fact that we use them so much in our day-to-day lives just isn't here in the UK. We've been very happy to kind of outsource all, you know, impacts associated with natural resources. I think it's probably pretty much fair to say, the last couple of decades at least. So we're coming at it from a slightly different angle here in Northern Europe, I reckon. Very welcome to read that afterwards. So yeah, just to set the scene, and because Jess got in touch after she'd seen my TEDx talk that I did a couple of years ago, in that I talk about this public perception of mining and the outreach events that we've been to. And what I love to do at these outreach events, especially, you know, we've done some at the Science Museum in London and some really quite awesome locations. You put up one big sheet of white paper, and you write mining on it, and you put up another big sheet of white paper and write renewable energy on it, and then just ask members of the public to put the first word that comes to their mind down onto that sheet. And, you know, for mining, we get responses such as, it's really dangerous, it's a dirty thing, everybody associates it with fossil fuels and oil and gas. Pretty much overwhelmingly, most people consider that mining must be bad for the environment. On the flip side, when you ask them to say what they associate with renewable energy, everybody can name solar panels, they'll talk about wind turbines. Everybody knows it's, you know, it's the green way to go. It's what we have to produce if we want to combat climate change. We've got to move away from this reliance on oil and gas. But then you ask them, so how do you build these, what do you build these wind turbines out of? And they're like, oh, well, you know, you've got 5 tons of copper in a classic wind turbine. You've got a couple of tons of rare earth elements, loads of steel, quite a lot of concrete, and they're like, oh, so where do you think that comes from? And I'm like, oh, hadn't really thought about that. And, you know, in the industry, we are very aware in the geoscience industry that all of the Earth's natural resources are so important. And if we want to combat climate change and harness wind power, solar power, you know, start to work out how to actually usefully get energy out of the oceans as well, then people with a geoscience background are going to play such a crucial role in that. And in no small part as well, we're the ones who understand how Earth works, we understand what past climate change looks like, and actually as a geoscientist as well, it kind of puts us in a really strong position to kind of act almost as stewards of the Earth. We're the ones who understand how all of these Earth system processes work and can think in this kind of big system way, and actually are going to play such a crucial role in combating this energy transition. And, you know, as we start to produce low carbon technologies on a much bigger scale, whether that low carbon technology is a wind turbine or is an electric car, we're actually going to need a whole suite of metals that historically we haven't really mined that much of. Things like tin and copper we've been mining for thousands of years. We understand where to find them, we understand how to extract them, and it's quite straightforward. Whereas actually when we start to look at the, you know, the chemicals that go into a battery, lithium, for example, yes, you know, we've got great spodumene deposits in West Australia. We've been mining it from salar deposits in South America for a long time. But actually, when it comes to putting it into something that's of a quality that can go into a battery, it actually becomes a really specialist chemical then. Lithium from one mine is not the same as lithium produced from another mine by the end. You know, you need certain levels of impurities and things like that, and it's actually becoming a very different market. And so for the natural resources industry, we need people who can find these deposits really efficiently, but we also need people who can extract them. And, you know, that means we're going to need a whole kind of new range of skills within the industry that we haven't necessarily needed quite as much over the last few years. It's going to be such a step change in the amount of natural resources that we need that actually we need to be embracing all of these new technologies as much as possible. And actually we need to make it an attractive sector to work in as well. I can't speak for Australia, but I know that in North America and in Northern Europe, the numbers of students applying to actually study geology and then who actually go into the mining industry is falling dramatically and has fallen really substantially over the last 5 years. And a lot of that is to do with the fact that people associate mining with climate change and they think it's part of the problem. So we're really not struggling. I think it's fair to say there's a lot of work going on now in the UK. Hopefully it's not too little too late to try and reframe mining as part of, you know, it's part of the solution to climate change rather than being part of the problem. So it's an interesting dynamic over here at the moment. But, you know, the global renewable capacity is expected to grow over 1 terawatt from 2018 to 2023, which is, you know, 46%. There was a great report that came out by the IEA, the International Energy Agency, this year, and it's got some mind-bending statistics in about quite how mineral intensive this energy transition is going to be. So, for example, they forecast that the global materials demand will more than double from 79 billion tonnes in 2020 to 167 billion tonnes by 2060. In the EU itself, over 30 million jobs are directly reliant on access to raw materials. Yet, at the moment, we don't really extract much of that metal at all. Like, the UK is totally reliant on imports of metal at the moment. And actually, producing energy from renewable sources is hugely mineral intensive as well. So a typical onshore wind plant requires 9 times more mineral resources than a gas-fired plant to produce the same amount of energy. And an electric vehicle has 6 times the mineral inputs of a classic combustion engine car. And actually, since 2010, the average amount of minerals that you need to generate a new unit of power has actually increased by 50% because the share of renewables has risen. So we need to find more of these raw materials, and actually we need to start finding these more niche materials as well that go into high-tech applications. So looking at lithium as an example, these supply chains are really global at the moment. And of course, that is going to have an impact on, you know, what's the carbon impact of producing these things. So at the moment, most of the world's lithium either comes from spodumene hard rock deposits in the west of Australia, which are high grade, high quality, and we know kind of how to extract them and how to process them. Or it comes from these salar brine deposits in South Australia, South America. It's not quite 7:30 yet. And so these salar brine deposits, these kind of form in really arid conditions. So in places such as the Atacama Desert, you've got high altitudes, you've got low rainfall, high amounts of evaporation, and you get these really salty brines forming just below the surface. What they do is they put boreholes in, pump these brines up to the surface, this picture, and they go into these huge evaporation ponds. So to give you an idea of scale, apparently it's 5.3 kilometers from the front of this picture to the distance, so to where you can see that pond at the back. So these are big things. They need a lot of space, and what they do is they pump water up into these evaporation ponds and then leave it for 18 months to 2 years. The water evaporates off, you slowly get a saltier and saltier and saltier solution left, and then eventually it gets to the stage where they're ready to put that into a processing plant on site and produce a mineral concentrate, lithium carbonate concentrate. It's a cheap way of doing it. You're relying on solar energy to evaporate off the water. So that's a renewable energy source. It's cheap. But equally, these are really water sensitive environments, and losing up to 90% of the water from below the water table through evaporation in settings like this is actually really impacting on local ecosystems and local communities there as well. And in parts of South America, I think it's probably fair to say that these local communities often don't have much of a voice that's listened to by government. And so you're seeing some real local communities are in areas not supportive of these projects at all, because it's taking away their livelihoods, it's altering the water table. They can't, they are often subsistence farmers, they can no longer support their families in that way. And it's having real environmental and social impacts from producing lithium in this way in some instances. So it's one of the oldest technologies in the world. It's a renewable technology, but actually it's not completely black and white. So anyway, once we've produced our mineral concentrate on site, we actually then need to upgrade it. We need to refine it into something that's battery quality. So more often than not, that then gets shipped over to China, because the Chinese over the last 20 years have been really smart in looking at what future technology is going to need and actually setting up the ability to refine these. So although the Chinese don't produce a huge amount of lithium domestically, they are currently responsible for refining between 50 and 70% of global lithium and cobalt. And lithium is not the only thing that they've been really clever in setting up the ability to refine it into the high purity chemicals that we actually need to use. So they refine over 35% of global nickel, 50-70% of lithium and cobalt, and over 90% of rare earth elements. So there's a pretty much a dominant control there by China. They might not necessarily be doing things to the highest environmental standards. So quite often gas or coal-fired power plants are used to provide the energy to refine these metals. So again, there's a carbon impact there. And also there's geopolitical ramifications as well, when we're so reliant on one country for being able to produce these things. So anyway, once we've had our lithium refined into battery grade lithium or battery quality lithium with its low purities, we might then ship it over to somewhere such as South Korea, where it can be assembled into battery cells and then into battery packs. It might then be shipped all the way back around to Europe to actually then be put into an electric vehicle in the north of England. So there's the chance that, this lithium can travel once or twice around the world almost before the lithium in your car is actually driven, before your car's actually driven a single mile. So at the moment, these supply chains are so much more global for producing an electric car than they are for producing traditional combustion engine cars. So the carbon impact of producing that is so much higher. Just to continue driving that home, this map on the left-hand side is quite out of date now, because 2017 was actually 4 years ago, which is terrifying. But it's still fairly true, I think. The vast majority of the world's lithium is either produced from hard rock sources in Australia or brine salar deposits in South America. What I think is the most important thing is the lack of any significant production from North America, from Europe, from Africa, and actually from Asia itself. There's very little primary production here. Europe and North America are some of the biggest markets for these energy transition materials, yet producing very little themselves. So there's a real drive at the moment in North America and Europe to find deposits of lithium, nickel, other energy transition metals that we might actually be able to produce domestically. And as I mentioned before, this is just to illustrate on the right-hand side that China are dominant in actually processing a lot of these chemicals. So that's all well and good, and hopefully a bit of a global scene setting as to, the moment these energy transition materials are produced across global supply chains, and actually China are very dominant in the processing of them. But just to put that into perspective, in 2021, the revenue from coal production is still going to be 10 times larger than the revenue produced from producing energy transition materials. So there's still a long way to go before we're producing fully renewable stuff. So just using what we're doing down in Cornwall now as a bit of an example of how we can approach trying to do mineral exploration, in a responsible way. The whole reason that we're looking for lithium and nickel and cobalt and things like this as an industry is because we want to facilitate the energy transition, because we want to help combat climate change. So that means we need to be looking for these materials in the most responsible way possible. Otherwise, we're producing them with a really high environmental and social impact. It kind of negates the whole reasons that we're looking for these raw materials in the first place. So this picture here is of some engine houses right out in the west of Cornwall. So Cornwall has got this, it's the most southwesterly part of the UK, and it's got this amazing mining heritage. Tin and copper have been produced here for 4,000 or 5,000 years. There's over 3,000 named mines in Cornwall, and as a region, it's produced over $50 billion worth of tin in today's money, $12 billion worth of copper in today's money. It is a globally significant mining region, but we haven't been producing any metal from here for the last nearly 30 years. And a lot of that's because when the tin price crashed in the mid-1980s, the final tin mines closed, and actually since then, there hasn't really been any production restarted. We've been outsourcing it. And people now think of it as kind of nice, quaint little industry that we used to have. But this is from a mine called Metallic out west. And so the shaft goes vertically down, and then the mine actually went a couple of miles out to sea. And there are accounts from the workers in the late 1800s that when it was rough and stormy, they could hear all the boulders on the seabed above them crashing, which must have been slightly terrifying, I think. And there was a horrible accident there once. But there are some dramatic engine houses perched on cliffs around Cornwall, and it's a really beautiful place if you do ever get the chance to come over here. But anyway, the geology. The reason that there are natural resources in the southwest of England are because of the granite. So there was a granite in place between 290 to 270 million years ago, and the final packets of that granite to be emplaced, what we call G5 granite here, are the most enriched in volatiles, including in lithium. So the kind of granite outcrops in 5 main places. We've got a place called Dartmoor in the east, Bodmin, and then we go over the St Austell area. And as you continue moving southwest, there's the Carmenellis granite and then the Land's End granite out to the west. So the Land's End granite is where that picture in the background has been taken. These pockets of the granite they kind of form topographic highs in the area as well. So they control, the landscape as you'd expect. And they're also interesting because they're relatively hot. So it means that we've got a lot more potential for geothermal energy. This is a heat map of the UK, of the Geology into the UK. And you can see there is a literal hotspot on the southwest of England. And that means that we've got the potential for geothermal energy down here as well, which is quite exciting. There's a lot of structures that are highly mineralized, and tin and copper mineralization is associated with the margins of the granite plutons. And we've got a lot of information about the subsurface from the areas where mineralization was noticed and extracted over the last few thousand years, but particularly from kind of the 1800s through to the mid-1900s. There's been a lot of mining that's happened. I said there's over 3,000 named mines, and we've got a lot of information about the subsurface in the form of old maps and plans and sections, which is pretty cool. You know, people found mineralization at surface and have effectively just carried on burrowing after it. So there's a real opportunity to look at this whole region with, in light of new, I'm calling it new, exploration techniques such as geophysics. So I think there's a lot that could potentially still be found down here. So lithium. Lithium was interestingly first discovered in Cornwall, first noticed in Cornwall back in 1864. And rather than being recognised in the granite rock itself, which is where it's from mica minerals in the granite, it was actually recognised in upwelling hot springs that used to plague the deep mines. So the reason that there are these engine houses dotted all across the southwest of England, such as the ones in those pictures behind, is because they needed to pump water out and dewater the mines. They needed to artificially lower that water table so that they could mine these steeply dipping narrow veins to deeper and deeper depths. Some of the water that they were pumping out was this meteoric water, so rainwater that had fallen on the top and percolated down. But actually, in certain parts of Cornwall, a lot of the water they were pumping up were from these upwelling hot springs. And so in 1864, Professor Miller from King's College in London asked someone to take a sample from him from one of these deep mines. I say deep mines. A fathom is 6 feet, which is about 1.8 meters. So 220 fathoms is about maybe 500 meters depth. So fairly deep for 1864. And so he took a sample from one of the levels around there, took it back to his laboratory in London, and was surprised to find that there was a significant amount of lithium in these upwelling warm waters. And then actually these upwelling hot springs in the deep mines were found all across Cornwall and actually are all relatively enriched in lithium. And he wrote a paper at the time which says, basically, this is academically interesting. These hot waters could be a potential source of lithium. So it's a shame we don't really have a use for it at the moment. So fast forward 150, 160 years, and here we are. So Cornish Lithium was founded 5 years ago now, and is exploring for lithium in geothermal waters, and actually now in hard rock and other battery metals down here in the southwest of England. Mineral rights over 500 square kilometres. Probably doesn't sound a lot if you work in Australia, but it's about 15 to 20% of onshore Cornwall. And we've actually just been awarded the rights to explore for lithium geothermal waters in 4 areas offshore of the coast as well. These geothermal waters are contained within big permeable faults, which have long strike lengths. And actually these faults extend offshore as well. So we're looking at the potential for maybe, now at some point far in the future, once we've proven it onshore, being able to access the water circulating in those big fault systems offshore as well. So just to touch on this, the UN Sustainable Development Goals, there are 17 Sustainable Development Goals, and actually mining, mineral extraction, has the opportunity to positively impact all 17 of those Sustainable Development Goals if it's done responsibly. And obviously, if it's done responsibly is the key factor here. Some of those SDGs it will have much more of an impact directly on than others, but actually it's really interesting that the UN SDGs recognise how natural resources really are at the heart of everything. And actually it tends to be this dichotomy of a lot of the world's natural resources are found in places such as DRC, other African countries, where local communities could really benefit from the responsible development of these natural resources. But it's just making sure that these local communities do actually see benefit from extracting these natural resources. That kind of old imperial foreign company comes in, white people take the natural resources and go, might employ locals briefly and then disappear. That has to change, that model has to change, and it is changing. There are so many companies out there doing really amazing good work now and trying to set things up to be much more sustainable and leave a legacy when the resources mined out. But there's still a really long way to go. So what are Cornish Lithium doing? I mentioned that there's many maps and plans and sections from the last few hundred years worth of mining. So we actually have a digital archive team who go and scan these things. So these are some drill holes and some steeply dipping structures. You can then trace on these structures in 3D space. So we can virtually hang these, this is a section through a mine, you can virtually hang these in 3D space. So you can see there we've got South Lode, Hot Lode, Wilmore, Elven, these are basically microgranite dikes. And you can see there are some drill holes kind of coming in from the right hand side and looking down. We can do that because these sections were drawn up every 100-meter intervals throughout the mine, both transverse and longitudinal. And we can put that into programs such as Leapfrog and develop these 3D models of the geology, the mineralization, etc., underneath the subsurface, which is pretty neat. And then we can use that to target our bores. We can combine it with geophysical information. So this is actually radiometrics from, and then we can use satellite information and start to build up as much of a picture as we possibly can about what's going on under the subsurface before we actually go and do any work in the field. We can then see where some of these big geological faults that contain these circulating geothermal fluids in at depth outcrop on the north coast. The centre of Cornwall is pretty vegetated, there's not really much opportunity to see outcrop, whereas actually if you go to the coasts, you can see these steeply dipping features poking out. So we've been flying drones, capturing, using a thing called structure from motion, which is really neat, which basically allows you to build these 3D digital models of what's happening just from taking 2D photos with a drone, or you can even do it with your phone camera apparently. And then they allow us to do VR field work back in the office. So if it's a rainy day, or actually we can't scale those cliffs in the same way, if you've really accurately GPSed in some certain points on your structure and motion models, you can then actually fit your model. And so if you measure that plane in the model, that should be exactly where it is in real life, if that makes sense. So we've got 4 major exploration streams and trying to do them all as responsibly as possible. And actually they're all considered, well, lithium from mica minerals rather than spodumene is considered unconventional at the moment. And actually extracting lithium from geothermal waters is also considered an unconventional deposit. No one's doing it commercially around the world yet, despite there being some really exciting projects that are getting there. So for hard rock exploration, as I mentioned, there are these pockets of granite that poke out all across Cornwall. Certain pockets are more enriched in lithium than others. And it so happens to be that the areas of granite that are more enriched in lithium than others coincide with where China clay or kaolin has been extracted for the last few decades. I say few decades, 150 odd years. In Cornwall, it's a tourist hotspot down here, especially since the pandemic. Everybody's been holidaying in the UK, and Cornwall is one of the most beautiful parts of the UK, and people come here on holiday. Tourism is the main driver of the economy since the mining industry stopped. And so many people, you mentioned mining, you mentioned hard rock mining and an open pit. People are like, you just can't do that in Cornwall, which is fair. I don't think you could open a brand new open pit in Cornwall, but actually a lot of people don't realise that there's a China clay industry here. And we've got huge open pits in the centre of Cornwall that have been extracting China clay for years. The China clay industry is in decline now, but you know, it still employs about 1,000 people. And so if we can go in and repurpose some of these old China clay pits and actually produce lithium from the micas in the granite, then that could be a really neat way of minimising the impact of producing lithium. You know, we're repurposing an old deposit. When you produce kaolin from a granite, you're actually concentrating up the lithium micas in the waste streams. So there's actually the opportunity to produce lithium from the waste that's been accumulated over the past 150 years as well. So we're investigating that potential at the moment. And, you know, as far as circular economy goes for the raw materials, if we can do that, that would be really neat. So we've done a couple of drill campaigns. So I say drill campaign 2 is underway. It's actually been finished now, and hoping to have our first resource statement out by the end of the year on our hard rock project, just on the first initial bit of the pit. But there's also an underutilised industrial infrastructure around here as well. You know, there's a huge railway line set up to move this material up country into ports, and it's being really underutilised now that the China clay industry is in decline. So we can repurpose all of that. Could be quite a neat environmentally responsible way of producing lithium. We're looking at using new technologies as well to be able to extract the lithium without having to do a roasting step. And you know, roasting, if you're producing lithium from spodumene, for example, you've got to roast it to really high temperatures. which generally means you use fossil fuels to reach those temperatures, which again has a carbon impact. We're looking at using hydrometallurgical process instead. We've not developed this ourselves. There are some very smart people from West Australia, actually, a group called Lepidico, and we've got a license agreement in place with them to use their LMAX technology, which allows you to extract a battery quality lithium product without a roasting step. Trials are underway and progressing really well with that. So that is what we're aiming to do here. So it's an example of how looking and embracing new technologies can actually help potentially unlock a new mineral deposit type. Then geothermal exploration. This is the stuff that I find really exciting. And we've got two different scenarios. We're calling it shallow, so less than 2 kilometers depth for the boreholes, and then deep, so down, you drill down to about 5 kilometers depth. And basically, the deeper you go, the hotter the temperatures are. So it makes sense, you're getting closer towards the center of the earth, so you've got temperature fluids down there. But drilling to about 2 kilometers, you can do with a typical mineral exploration rig, just about. Drilling down to 5 kilometers, you've got to use oil and gas technology. So it's a step change in the cost. So we've kind of got these two different scenarios. You get warmer waters, so at 2 kilometers depth, you probably get 70 to 90 degrees centigrade waters, which are warm. They've got lithium dissolved in them. So heat is a significant byproduct of that. Whereas if you drill down to 5 kilometers depth, you should get temperatures of about 190 degrees C. So by the time you pump that up to the surface, it's still well over 100 degrees Celsius. So you can flash it off, that steam can turn turbines, you can generate power as well. So you can generate geothermal power. So the lithium grades in the hotter waters are also higher. So what would be really neat is if you can use that geothermal power to then process your lithium out of the water, so to power your lithium extraction plant. So there really is the opportunity for it to be kind of net zero carbon produced lithium, which would be pretty cool. So we're looking at these two different scenarios. We're hoping to drill another borehole for around about 2 kilometers depth to intercept what we're calling shallow geothermal waters in the next few months, which is very exciting. And then there is actually, so far, one deep geothermal project in Cornwall. We didn't drill the boreholes ourselves, but we're partnered with them to see if we can actually extract lithium from it. They drilled down to 5.2 kilometers depth in central Cornwall, and we found that we've got the highest lithium grades out of any reported geothermal waters globally here. So it's 262 parts per million lithium, which doesn't sound a lot, but if we just spend a moment looking at this graph here, what's exciting about it is actually the amount of lithium relative to the total dissolved solids, so the saltiness of the brine. So seawater, total dissolved solid is about 35 grams per litre. If you look at these salar deposits that you get in South America, they're really salty, so you can get 250, 350 parts, grams per litre total dissolved solids. Oil field brines, again, pretty salty. Geothermal brines can be a huge range from published data that's out there. What we found at United Downs, which is this red blob on the left, is that actually, although you can get 10 times as much lithium in these salar deposits, you can also get an order of magnitude more saltiness. So when you're trying to selectively remove just the lithium compounds from the water, that can make it quite difficult. So actually the relative amount of lithium to everything else in the water in these Cornish geothermal waters seems to be much higher. I don't know if I've explained that very well, but I hope that makes sense. And we're looking at the potential to co-produce geothermal power and lithium. And we're going to have a pilot scale plant built by March next year, which is very exciting. So they're currently in the process of building a power plant on this geothermal project. Once the water is pumped up from the surface, it will go through the geothermal power plant. It will then be routed through a lithium extraction pilot plant, and then the water will be re-injected back down to depth at 2.5 kilometers, where it can reheat up, potentially recharge lithium as well. So when we talked about lithium right at the start of this, we looked at those salar brine deposits and the big evaporation ponds that we have in parts of South America. Aside from the environmental and social impacts of that, There are many reasons that you can't rely on evaporation in Cornwall. One, it rains far too much. If I look at my window right now, it is vile. Secondly, we don't have the space to have kilometres and kilometres of ponds set up. It just wouldn't work. And actually, thirdly, there's new technology out there, which means that you can selectively remove just the lithium compounds from the water over much shorter timescales, a matter of hours rather than 18 months or 2 years. And yes, it's more expensive. Yes, it's more power intensive. But for us, that's the only viable route. So we're looking at different direct lithium extraction, DLE technologies. These can be using things from ion exchange membranes, different sorbents. So the idea is you want to just remove the lithium atoms from the water. And there's various technologies out there. Again, we haven't developed our own proprietary technology to do that. We're looking to work with people who've been smart enough to develop that themselves. So we've trialled a number of these on site in central Cornwall recently. There you go, this is just a little schematic, so finishing up to show the idea is you pump hot water up from depth, goes into your geothermal plant, water will be flashed off, use working fluid, generate geothermal power. Heat is also a significant byproduct. It will then be routed into a lithium pilot plant where we'll extract the lithium from those waters before the water is then moved back down to depth. So it's really, you're looking to just selectively remove the lithium compounds from the water. So there's very little waste associated with the process as well. So as new ways of mineral extraction go, it could be quite neat if we can get it to actually work in a commercial way. And then finally, just looking at the time, just to wrap up, diversity is really important. You know, it's such an exciting, geoscience is such an exciting field to be in. There's so many different things you can do. You can be somebody who's an expert in past climate change. You can be somebody who understands oil and gas resources, and now is looking into carbon capture storage technology. As geoscientists, we've actually got an appreciation of wind, solar, things like that. And we need to, I don't know what the situation is like in Australia, but in Northern Europe and North America, we need to make the sector so much more appealing to students to come into. They need to see it as an exciting way to actually play a meaningful role in tackling climate change. Whereas at the moment, a lot of people think it's part of the problem. And there are some fantastic organisations out there that are helping to do this and trying to promote it to younger people. You know, we need data scientists. We need a whole variety of roles that might not be people going out and bashing things with rock hammers, which is what a lot of us really love doing. But equally, that doesn't appeal to everybody. It's not just field work. So we need to showcase all the variety of different jobs and roles and things that there are out there. And that's why things like LinkedIn can be really powerful. Doing talks such as this, you know, one absolute benefit of if there really are any benefits of the pandemic, I think global collaboration has become so much more of a thing now. It's fantastic. Role models are important. I think it's so important to showcase the work that you're doing. You know, you're doing something interesting, shout about it, talk about the impacts of it and why it's exciting. We need to try and get more people engaged with geoscience. And then, yeah, groups such as the Young Mining Professionals, I know there are Australian chapters, and Women in Mining can be awesome in helping to promote diversity and trying to get a young generation into the industry, whether that's through scholarships, events, networking, hooking people up with internships, going out and doing advocacy and talking. There's so much that the industry can do, and there is a long way to go still, I think. So just to sum up then, thank you so much for sticking with me. Looking forward, you know, this energy transition is going to be hugely resource intensive. It's going to happen. We are going to move away from this reliance on oil and gas and fossil fuels. So we need to do that as rapidly as possible. And actually, geo-resources are going to play a huge role in this. So with the people with the skill sets to actually understand this, we're going to be really important. I think we've got a real responsibility to make sure we're exploring for these things as responsibly as possible. You know, we're using satellite imagery, we're using remote sensing, we're using data science to try and come up with neat ways of automatically looking for things. Using machine learning and AI to go through these big data sets and see if we can understand mineral systems approaches better, for example. We also need to use new technologies to help us actually extract these materials as responsibly as possible. We need to be working with people to make sure that electric cars, for example, are designed for second life and recycling. There's such a huge amount of work to do. We haven't even touched on the circular economy here and in life cycle assessments and things like that. But the industry is taking great steps to becoming more transparent and responsible. And I just think it's such an exciting place to be. And thank you very much for listening to me.
Thank you so much. That was so interesting. So I really appreciate you taking the time.